Good to have you on SpaceX Daily, Episode 6, coming to you from Vancouver. It's June 17th, 2026. Here's what's happening at SpaceX today. 5 uncrewed Starships aimed at the 2026 Mars window will test whether orbital refueling can deliver the propellant margins needed for crewed flights inside 5 years. 5 uncrewed Starship vehicles are now projected to launch toward Mars in the narrow 2026 planetary alignment window. That timeline would keep the shortest transfer trajectory open and position the program for our first crewed landing attempt by 2031 if the uncrewed flights succeed. The entire sequence depends on repeated orbital refueling to top off the departure stage, plus reliable trans-Mars injection burns once the stack is full. SpaceX expects the first integrated tanker-to-ship demonstration later this year, which would retire the largest remaining technical risk before the window opens. Remember that Mars architecture questions were last discussed on Episode 4. Today's update shows the uncrewed fleet size and refueling count have now been locked to close the energy budget. While that architecture work continues on the East Coast, legacy Titan hardware at Vandenberg has been cleared to open new high-inclination options. The U.S. Space Force outgrant issued last year cleared the way for SpaceX to remove the old SLC-6 structures. With those pads now empty, the site can be rebuilt for Starship-class vehicles that will fly polar and high-inclination missions once a new flame trench and tower are in place. The modernization expands SpaceX launch geography beyond the existing Falcon pads at Vandenberg and supports higher overall cadence. Observers noted that the cleared Titan-era equipment had stood since the 1960s, marking a clean break for the next generation of vehicles. High launch rates that enable constellation growth also produced another milestone yesterday when the 1500th Starlink satellite of 2026 reached orbit. The spacecraft flew on the first Falcon 9 mission after the June 12th NASDAQ listing. That brings cumulative deployments for the year to 1,500 and keeps both routine replenishment and direct-to-cell capacity on schedule. Additional Falcon 9 flights remain manifested through the end of the month to sustain the same pace. Engineers in the community are already modeling how the same high cadence will affect long-term constellation maintenance above 6,000 operational satellites. Rising traffic also created a close approach yesterday when fragments from a Chinese upper stage passed within a few kilometers of active Starlink's planes. Operators tracked the debris in real time and executed avoidance maneuvers on multiple satellites. The event underscores both the growing congestion in low Earth orbit and the effectiveness of Starlink's autonomous collision avoidance software under real conditions. Community threads flagged the pass as a reminder that onboard autonomy will need continued refinement as launch traffic keeps climbing. Debris fragments originated from a recent Chinese upper stage breakup event. Multiple Starlink satellites received updated ephemeris data within minutes of initial detection. Avoidance burns were executed autonomously on at least 4 spacecraft to maintain safe separation margins. Real-time coordination between SpaceX operations and external tracking networks prevented any conjunctions. The incident occurred at altitudes overlapping the primary Starlink operational shells. Continued growth in launch activity from all providers increases the frequency of such encounters. Onboard software logged the full sequence for post-event analysis and algorithm tuning. One thing worth watching is that astronomers continue to raise concerns over the planned dense AI compute constellation and its potential permanent impact on ground-based observations. Existing wide-field surveys are already contending with Starlink trains, and the new planes would add both light pollution and radio interference unless narrower shells or onboard optical mitigation can be proven at scale. Professional observatories have documented measurable increases in background sky brightness during satellite passes. Radio frequency surveys report elevated noise floors in bands used for pulsar timing and cosmic microwave background studies. Proposed mitigation approaches include narrower orbital altitude bands that reduce overlap with major telescope pointings. Onboard visors or low reflectivity coatings remain untested at the scale of thousands of additional satellites, Modeling indicates cumulative effects could limit discovery rates for near-Earth objects and faint transients. International astronomical unions have requested formal consultation channels with constellation operators. No quantitative mitigation thresholds have been demonstrated in current orbital test articles. On the AI front, the Department of Justice has moved to dismiss the NAACP lawsuit against xAI's Memphis data center, citing the facility's role in training large models that support SpaceX orbital data center plans. Court filings note that the turbines in question already operate under existing permits. The motion emphasizes alignment between the Memphis cluster and national priorities for large-scale compute. Training runs at the site directly feed orbital data center architecture studies under development. Existing air permits cover the full installed turbine capacity without modification. Dismissal would allow uninterrupted construction timelines for additional power and cooling infrastructure. SpaceX engineering teams have referenced similar power-dense compute nodes for future Starlink-adjacent payloads. The filing contains no new environmental data beyond previously submitted permit records. From an engineering standpoint, the 2026 Mars window plan rests on a straightforward propellant mass budget that can be walked through from first principles. A Starship departing Earth orbit requires roughly 1,200 tons of propellant after the initial boost to achieve trans-Mars injection energy. Each tanker rendezvous can deliver about 100 tons, so 2 carefully timed flights close the gap when aerobraking is used at Mars arrival. Multi-layer insulation plus solar reflective coatings must then hold daily boil-off below 0.1%, so the same stack remains viable for crewed missions. Success here removes the historical dry mass penalty that made round-trip interplanetary flights uneconomical. Every kilogram saved on orbit translates into hundreds of kilograms of delivered payload at Mars. And a quick market note, SBCX closed at $201.80, down 2% from the previous session. Before we go, watch for the first integrated refueling test that must happen before the 2026 Mars window opens. That's your SpaceX news for today. SPCX is trading at $201.80, down 2%. If the show saves you time, a rating or review on Apple Podcasts or Spotify genuinely helps new listeners find it. I'm Patrick in Vancouver. Thanks for listening. See you tomorrow. And before you go, this show is part of the NERA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Fascinating Frontiers a listen, the most fascinating news from space and science. You can explore the whole lineup at neuranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.